Okay, so how we're going to do this is, I'm going to ask for answers, and then I'm going to kind of give you a weird-looking face, like, are you sure that's what you mean? And then I will go on my rant. So who can tell me, what is a scientific model? And the answer is not the, person modeling the scientific lab coats, the white coats, and the catalog. That's what is a scientific model? Anna? Is it what? Proof of something, she says. Does anyone want to expand on that? I saw a hand somewhere over here. Scientific model. Can you give me an example, Anna? You don't know? Oh, Anna? A Bohr model? That's a great one. How did you know it's a model? It has the word model at the end, right? In grade 9 or grade 10 chemistry, you talk about the Bohr model. You know, the electrons moving around the outside. Is it true? Turns out it's not exactly 100% right. Good question. We'll get to that in a minute. What is a scientific law? Who wants to be brave? Zoe, what's the scientific law? No, you want to be brave. Sorry. Don't want to. Okay. Anna's got her hand up again. She's brave.
Something that's been stated.
So all I have to do is state it and it's a law? Really? I have a PhD and I'm a lottery winner. Done.
If it's proved.
It's proved. Jason, what say you? What is a scientific law? Something you have to follow in science. I mean, kind of like a law that says you got to stop at stop signs. Is that what you mean?
Yeah.
Oh, you in agreement with that? So what would be an example of a scientific law? An example, I know you've heard of them in science.
Newton's laws.
Newton's laws. 3 laws, right? Newton's laws. Maybe you got that one. What's Newton's law? Going with the formula. F equals ma. It's the law, right? The F is the M times the A. Gotta do it. It's the law. Okay. You'll notice that I'm not saying right or wrong just yet. What is a scientific theory? Let's go with Trent. No? Count? No. Yeah, count, right? Did I get it right? Yeah. What's the scientific law? Or sorry, scientific theory. Don't know? Lane? Okay?
Laws. Wait, I'm three.
Theory. Oh, that's okay. Never, there's no right or wrong here. I haven't told you the right answer.
Like a theory is like when it's like proven or something.
A theory is when it's proven. Megan, what do you say? Valerie? What are the Valeries?
Something that a scientist tries to prove and it's
Something that a scientist tries to prove and
proven.
it's right until it's proven wrong. Jen? Something want to add anything?
Yeah, something like a hypothesis.
Something like a hypothesis. Hypothesis is another word, but it's kind of related, right? Okay. Who can give me an example of a scientific theory? Do you? Not a clue. It's easy because it's like law. It's not the word law, and like Newton's law. Big Bang Theory. Well done, Nick. What does the Big Bang Theory explain? Origin of the universe, right? Okay. Number 4. How do we prove scientific theories? So, again, notice I am not agreeing or saying that's right or that's wrong. Because some of the things you're saying are right or wrong, or are right or wrong. How do we prove scientific theories? Go ahead, Sarah. Experimenting? Trying? Do scientists ever sort of like, if you do your experiment and you say, hey, I found this out, do other scientists try and find out if they came up with the same thing?
Probably.
Yeah, that's called peer review. Peer, what does peer mean? Not the part where you put your boat, not that kind of peer. What's a peer? A friend, a colleague, someone that is sort of at the same sort of level, I guess you could say, right? Like, A jury of your peers in law means like, if you're up on charges, a jury of your peers is someone that's from the same area and is sort of related to you, has the same values kind of thing. So a scientific peer is someone who is related in that field, has some knowledge. Would you be scientific peers to some, say, climate change scientists? No. You don't have to back up. Okay? Okay, number 5. This is an easy one. Do you believe in atoms? Who can I call? Do you believe in atoms? Yeah? How come? Because they've been proven. How do you know? Because that's what you've been taught. So you've taken the word of some science teacher before me. Ever seen an atom, Zoe? Never? Never seen an atom. Lane, ever seen an atom? Absolutely. You're looking at some right now. You ever seen a single atom?
Where they like rearrange them.
Oh yeah. Animation or actual real life?
Rearrange them with like magnetic.
Oh yeah. I don't think anyone's actually seen a real atom. There's things called electron microscopes that are pretty good, but most high school kids never seen an atom. But just like Amber said, you've been taught it, and so you've relied on someone else's knowledge, and you've trusted them. Do you trust me to give you the truth? Well, we did tell you about the Bohr model. I so that's not entirely true, right? So yeah, we do rely on experts, if you will. I'm getting at a point here, don't worry. How are science and art similar and or different? Let's start with these ones. How are science and art different? Let's go with that. Getting away, one way that science and art is different. Besides their spelling. Go ahead, Dave. You don't paint science. That's a good point. Okay, I'll give you a little bit of a hint. In science, usually there, like when I give you a question in a textbook, usually there is a right answer. Is there a right answer to art? I mean, well, okay, English art, suppose. I'm thinking like more like painting and dance and music and stuff like that, right? There's generally not a right answer. There might be a right way to do something or other, but science is a little bit more, I would say, structured, straightforward, less room for interpretation, maybe. Okay, interesting. What about the same? How are science and art the same? This is a hard question. Very few students ever get this. They have shapes.
We usually have a final product.
Okay, I would agree with that. That's not what I'm looking for. But here's my answer. Do you have to have some general understanding of science to truly appreciate good science? You have to have some basic knowledge to say, oh, that's pretty cool, that's good, I get that, or that's amazing. You have to have some general understanding of science. Would you agree the same is true with art? No? Like if you go into an art museum, I went to an art museum last summer in Chicago, and it was pretty cool. There were some pretty cool paintings, but there's some pretty weird stuff. I was like, I don't get it. I don't have much appreciation for art. Right? There's some I can get. You have to know something about it to sort of appreciate it. And the same is true with science, right? And that is kind of one of the goals of public education, is to give people that ability, right? Okay, number 7. Some astronomers say the universe is expanding. Some say it is shrinking, and others say it is remaining a constant size or it is static. Some astronomers say the universe is expanding, getting bigger. Some say it's shrinking. Others say it remains a constant size. It's the same size. How can scientists arrive at a completely different conclusion when they look at exactly the same evidence? What does that mean? Jason, that's good. They have different points of view. They have different theories that they are trying to confirm. And that is the danger, is that scientists always want to try to confirm their theory, but really what they should be doing is trying to disprove. And it's a danger. It's human nature to try to prove that you're right. We do it all the time. Right? So there's a very real danger. in the future, this is grade 11, in the future you're going to be researching a gentleman by the name of Robert Millikan. He's got a famous experiment. It's called the Millikan experiment. He had an idea and he looked for proof of that, and there was some controversy with his methods, which you'll discover. Yeah, that's a good example of that. What about number 8? You should know the answer to this. Who have I not called them? No. Can scientific theories change? Can you give me an example? Okay, tell me why. Because you get, or new evidence is found? Okay. What about scientific models? We have the Bohr model. Here, I'll give you another example of a model. It's right up there. Is the globe a model? Why? Why is that a model? What makes it a model? Can you see the globe? Go outside and look, right? But you only see a small portion. Even if you go to the moon, you're only seeing sort of, you're from so far away. But a globe like that gives you kind of a sense and appreciation of the whole thing. So how would you, if you had to define what a scientific model is, what would you say if I told you that that was the example I wanted to use? Why is a globe a scientific model? Well, it's physical. You can touch it. Is it smaller than the real thing? Is that always true with scientific models? Sometimes they're. I'll give you an example. Something's bigger. Okay, like one of those models you build in Mr. Bernatster, right? Or the Bohr model. So sometimes models, they shrink them, depends on their original size. Okay, we're making some good progress here. Okay, I'm going to show you a video. It's really good, but the guy's a mumbler. Barely hear him. So I'm going to put it might be better now that I got better speakers. But you really, really have to listen carefully. But what he has to say is really, really super important. I wish he'd remake the video with better audio. I'll do this just to make it better. What was the number one thing that you got to take away from that? You can't discount something just because it's just a theory. Just a theory implies that you're waiting for it to be a law. And guess what? Will it ever happen? No. Theories do not become laws. I'll say it again in case you didn't miss the cue. Some of you figured it out. You're supposed to write that down. Theories do not become laws. Oh, it's just a theory. Yeah, it's a well-researched explanation of what's going on. That's what a scientific theory is. And you see this all the time. He alluded to people that don't believe in evolution. We are now in an age where there are climate change deniers. And they'll say, well, it's just a theory. Yeah, it's a scientific explanation for what's going on. It won't become the law of climate change. Laws are descriptive. They tell you what will happen. It was Colby, I think, who said Newton's law, right? Maybe it was me. F equals ma, right? It tells you what the force will be when you've got a mass and an acceleration. I mean, you're pretty addicted to that phone, aren't you? Okay? Theories do not become laws. Have I made that clear? Now, this is dangerous territory, and I'm going to show you another video. Okay? This gentleman that you're going to hear is an American politician. This is from a few years back. This gentleman is Governor Rick Perry of the state of Texas. Okay, so this starts 20,000 BCE. Used to be known as BC. It's now known as BCE. I believe it stands for before the Common Era. Right? The year zero, the year that Jesus was supposedly born. They sort of arbitrarily picked a point, right, and said that's zero. Not really the best system, but that's the way we're stuck with. Anyways, okay, so 20,000 BCE. Now this zero mark right there, that's the middle. Keep an eye on that. Temperature compared to the 1960 to 1990 average. So they took the global average temperature, averaged it out between those 30 years, 61 and 90, and we're going to call that zero, that average. Okay? And then anything below is below average, and anything above is higher. Okay, so 20,000 years ago, the global temperature was about 4.3 degrees Celsius below that. It was considerably colder, on average, throughout the Earth. Now, we all know, here in Canada, the temperature can go right to plus 40 all the way down to minus 40, right? We have wild swings. So you got to keep that in mind, what the world average means. What do you think the average temperature here in Dauphin is? Just as a guess. What do you think? 11. What do you think? I would say, would you say the average temperature is above 0 here in Dauphin? I would say yes. 11 seems a smidge higher than trend. I don't know, actually. Not a bad guess. If I had to guess, I'd say something like about 8. I'll look that up. Anyways, so 20,000 years ago, the global temperature was about minus 4.3 degrees Celsius. Okay, so Boston is buried under almost a mile of ice. Glaciers reach as far south as New York City. Things are cold. The world is about to warm up. Now, how much is that whole bit of time? 500 years. Not much has changed. Your guys' lifespan is less than 20 years. Mine's about 50. 50 years, my lifespan on this chart, we're talking, that's 500. Each one, can you see that faint line right there? That's 100. That's my wife's grandmother's lifespan. She's 102. My lifespan is from there to there. Yours is like just one of those little, yeah. Okay, so 4.3, right? Is it warming up? A little bit. How fast? Really? It's still, this is minus 4. That's 1,000 years. Change in the Earth's orbit means that more sunlight reaches the polar ice. Is it warming up? Ice sheets are starting to melt. Hundreds and hundreds and hundreds and hundreds of years. Temperatures have been creeping upward. CO2 levels start to climb. Now we're at 1,700 years. We've gone 3,000 years. Has it even gone above minus 4? No. Warming speeds up. Ooh, look at how fast it's speeding up. Still pretty cold. I should put a hat on. In what is now France, humans paint murals on the walls of the Lascaux caves. How much has it warmed up in that 5,000 years? A little bit. A little over half a degree. Ice sheets around the Alaska shrink, exposing a land bit between Asia and North America, where they believe the first humans to our continent arrived. Humans arrive in North America. There we go. Cool. Yeah, right? Cool. There's 0. Minus 1, minus 2, it's still minus 3 degrees below the global temperature. 6,000 years have gone by. The edge of the ice withdraws from New York and retreats north. Humans domesticate dogs. Woolly rhino goes extinct. We're still 2.5 degrees below. How fast is it warming up? Now it's starting to pick up, right? But each one of these, again, is 100 years. Washington State is scoured by huge floods, glacial dam. Okay, blah, blah, blah. Ice sheets withdraw from Chicago. Okay, Syria, we got humans there. Temperatures start to decline, mainly in the northern temperature. See how it goes down a bit? Humans reach Argentina. Now we're at minus 2 here. Warming resumes. Ooh, we did quite a bit of warming in that. Again, this is how much? 500 years. It went from minus 2.8 to about minus 2.4. Ooh, it's really warming up now. Saber-toothed tiger goes extinct. We're talking 9,000 years, 11,000 years ago. Horses disappear from North America. Last North American Pokemon go extinct. That's not a fact. Temperatures reach modern levels. So this is at 0. Rising seas cut off the land between North America and Asia. Cattle domesticated. We are now 8,500 years before the birth of Christ. 10,000 years ago, we are now just slightly warmer. Just a little bit. Ice sheets retreat across the Canadian border. Things are warming up. Temperatures start to level out slightly above. The warm, stable period is called the Holocene climate optimum. China, blah, blah, blah. 6,000 BCE. Humans developed copper metalworking, good for us. Gold metalworking, invention of the wheel. Earth begins to cool slowly, mainly due to regular cycles in its orbit. Look how much it cooled. You can barely tell. History of writing, 3,500 BCE. Earliest human whose name we know, Pharaoh I don't know. 3 sovereigns, 5 okay, so this Great Pyramid constructed. Stonehenge completed. Chariots developed, 2000 BCE. Alphabet writing developed in Egypt. We're right at 0 here, right? Polynesians explore the Pacific Ocean. First Olympics, Confucius. Stuff in the movie 300, but regular speed and with more clothing. About 500 BCE. Alexander the Great, paper invented. Julius Caesar, Roman Empire. Jesus, Pompeii exploded. We're talking like year 0. Okay, where is the temperature? What's the temperature been doing? Slowly cooling. But again, each one of those blocks, 500 years. Muhammad, Tangazi, 500. Leif Erikson, we're right at 0 here. Medieval warm period in Europe and some northern regions. Magnetic compass variation, Genghis Khan. We're now, how much are we below our average? -3. I know it's taken a while here. European Renaissance, Shakespeare, Newton, the Little Ice Age. It cooled by about 0.4 degrees. We're in the year 1600 now. We're going to start zooming in a bit. 1700, steam engines. We're slightly below. United States independence. Industrial Revolution. Some of you have been looking over there to see what the answer is. Yeah, that's the reaction you're supposed to get. Airplanes, world wars, nuclear weapons, the internet. This is the year 2000. What year are you guys born? The year 2000 is right there, right? Look at the rate of warming. Have you seen that rate of warming? And the answer is no, you haven't. This is the current path that we are headed on. What year were you born? 2000. If you live to 100, on the projected path, 0, plus 1, plus 2, plus 3, plus 4. This is an optimistic scenario. We might be able to limit it to that. This is the best case scenario, assuming that we all turn off our cars and never start them again. Now, granted, this is pretty simplistic stuff, right? Is it scary? I'm sorry. I'm 50. I've only got 50 more years, hopefully. I don't see those Leafs when they come. They might have to have the parade on boats, though. I'm sorry, you guys. You got 80 years, roughly. This is evidence. What is climate change theory? It is an explanation for what is going on. Will it be proven? No. Theories are not proven. They just keep adding to the evidence. It will never become the law. Have I entertained you enough? Have I ranted enough? I've got more. I know some of you are looking at the clock going, oh my God, is he going to do this for the entire period? Is this important stuff? I don't expect you to go out and save the world from climate change. What I do expect you to do is call people out that say, just a theory. I do expect you to do that. Especially politicians of any political stripe, right wing, left wing, or down the middle. I expect you to say, just a theory? Did you not pay attention in science class? That is my goal today, to get you to understand that. I got a couple more for you here. This one is far easier to understand and is probably better than me.
Chat with a friend about an established scientific theory, and she might reply, well, that's just a theory. But a conversation about an established scientific law rarely ends with, well, that's just a law. Why is that? What is the difference between a theory and a law? And is one better? Scientific laws and theories have different jobs to do. A scientific law predicts the results of certain initial conditions. It might predict your unborn child's possible hair colors, or how far a baseball travels when launched at a certain angle. In contrast, a theory tries to provide the most logical explanation about why things happen as they do. A theory might invoke dominant and recessive genes to explain how brown-haired parents ended up with a red-headed child, or use gravity to shed light on the parabolic trajectory of a baseball. In simplest terms, a law predicts what happens, while a theory proposes why. A theory will never grow up into a law, though the development of one often triggers progress on the other. In the 17th century, Johannes Kepler theorized cosmic musical harmonies to explain the nature of planetary orbits. He developed three brilliant laws of planetary motion while he was studying decades of precise astronomical data in an effort to find support for his theory. While his three laws are still in use today, gravity replaced his theory of harmonics to explain the planet's motions. How did Kepler get part of it wrong? Well, we weren't handed a universal instruction manual. Instead, we continually propose, challenge, revise, or even replace our scientific ideas as a work in progress. Laws usually resist change, since they wouldn't have been adopted if they didn't fit the data. Though we occasionally revise laws in the face of new unexpected information. A theory's acceptance, however, is often gladiatorial. Multiple theories may compete to supply the best explanation of a new scientific discovery. Upon further research, scientists tend to favor the theory that can explain most of the data, though there may still be gaps in our understanding. Scientists also like when a new theory successfully predicts previously unobserved phenomena, like when Dmitry Mendeleev's theory about the periodic table predicted several undiscovered elements. The term scientific theory covers a broad swath. Some theories are new ideas with little experimental evidence that scientists eye with suspicion or even ridicule. Other theories, like those involving the Big Bang, evolution, and climate change, have endured years of experimental confirmation before earning acceptance by the majority of the scientific community. You would need to learn more about a specific explanation before you know how well scientists perceive it. The word theory alone doesn't tell you. In full disclosure, the scientific community has bet on the long horse before. Alchemy, the geocentric model, spontaneous generation, and the interstellar ether are just a few of many theories discarded in favor of better ones. But even incorrect theories have their value. Discredited alchemy was the birthplace of modern chemistry, and medicine made great strides long before we understood the roles of bacteria and viruses. That said, better theories often lead to exciting new discoveries that were unimaginable under the old way of thinking. Nor should we assume all of our current scientific theories will stand the test of time. A single unexpected result is enough to challenge the status quo. However, vulnerability to some potentially better explanation doesn't weaken a current scientific theory. Instead, it shields science from becoming unchallenged dogma. A good scientific law is a finely tuned machine, accomplishing its task brilliantly, but ignorant of why it works as well as it does. A good scientific theory is a bruised but unbowed fighter who risks defeat if unable to overpower or adapt to the next challenger. Though different, science needs both laws and theories to understand the whole picture. So next time someone comments that it's just a theory, challenge them to go 9 rounds with the champ and see if they can do even better.
Did that do a better job explaining it than me? Thank you. There's one more, but I'll save it for Monday because I pushed my limit here, haven't I? Have you managed to stay engaged for a whole period? I hope so. It is kind of important stuff, right? Don't let people say it's just a theory. That's my point.
It's just a theory.
Maybe what I'm saying is just a theory.
Exactly.
Question everything. Ask for sources. Remember, there's no school Monday. Don't forget. Well, for you guys. I'll be here. We'll pick up right there on Monday.